Okay, now it's counting.
Timing, yep.
Yeah.
Hello and welcome. Today we're working on trig exact values. So what we're doing is trying to find some exact values that allow us to make our calculations a little easier. You might have seen these triangles before, and what we do here is we've got a triangle that's going to be an isosceles triangle with these two sides the same. So therefore these angles here have to be 45 degrees for each of them. Why? Triangle, 180 degrees. We've got to have 180, 90 in there, 90 there, we're set. We also find that if we place this as side length of 1, then this one here needs to be side length of 1 as well. So then to work out this side length, well, we just use a bit of Pythagoras. 1 squared plus 1 squared is 2. Take the square root of that, we're going to end up with square root of 2. So that's one triangle we're going to use. The other one is going to be a 60-30 triangle. So up here we're going to have 30 degrees, and in here we're going to have 60 degrees. Again, 180 degrees in our triangle, so we're good with that. We're then going to look and say, well, let's call this side down here, let's make that 1 as well. The sizings don't really matter. What's more important is that the Pythagoras works out for us, and with these angles it's going to work out. And what we find is, if I make this side length 2 over here, and if I was to draw that triangle like that, then this side over here would have to be the square root of 3. Why? 1 squared plus the square root of 3 squared is going to give me 3. Combine them, that's 4. Square root of that, 2. So that's how we get those numbers there on our exact triangles. They're just handy triangles to know. And what we can then do is jump into a table like this, where I've got 0, 30, 45, 60 and 90. And you'll notice that most of those angles occur in these triangles. So we're going to use the dimensions that we've got on here. The other thing we've got to remember with our sine, cos, tan is just our SOHCAHTOA to get the ratios the right way. So we've got sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. So we're going to use those and these angles to get some exact values here. Let's ignore 0 degrees for a moment. We'll come back to that one. And ignore 90, we'll come back to that one as well. Let's look at 30 degrees here. So we're going to do the sine of 30 degrees. So we're using this part of our trig ratios. Sine is opposite over hypotenuse. And if we're looking at 30 degrees, we've got to be working from this angle here. So sine of 30 degrees is opposite over hypotenuse. So the value of sine of 30 is going to be 1 over 2. So we'll just put in a half there. If we're going to do 45 degrees, we've got to flip to this other triangle. Here's a 45, doesn't matter which one we use. Sine is opposite over hypotenuse, same thing. 1 over square root of 2 this time. So we've got 1 over square root of 2. 60 degrees, we're back to this triangle down here. Sine is opposite over hypotenuse, square root of 3 over 2. Leave the 90, leave the 0, we'll come back to those. Let's look at cosine. So now we're looking at this section here, adjacent over hypotenuse. 30 degrees to start. Sine of 30 is the adjacent divided by the hypotenuse. Square root of 3 over 2. 45, we're in this triangle. Doesn't matter which one we use. Cos is adjacent over hypotenuse. 1 over square root of 2. This one here, 60 degrees for cosine. Here we are. Cosine of 60 is adjacent over hypotenuse, 1 over 2. Now you probably look at these numbers, or hopefully you do, and you spot that actually these were the same, these are the same, and these are the same. And they do follow each other in that way, as one is getting bigger, a half, 0.707, 0.866, it's getting bigger. This one is getting smaller. So let's do our 0 and 90 then. What we find, and if you remember the unit circle idea, so our unit circle here, we've got sine measured up here, we've got cos here. So when I pick a small angle, I get a relatively large cos value and a small sine value. As the angle increases, my cos value decreases, but my sine value increases. Take an even larger angle, sine value has increased again, cos value has decreased again. So it's kind of logical, we're starting large and getting smaller. And where do we start? We start at 1 and we go down to 0. With sine it's the opposite, we start at 0 and we end up at 1. And that's because the unit circle here has a radius equaling 1. So when we're at 0 degrees, 90 degrees, 180, 270, our sine and our cosine is going to be 0 or 1. Let's do tan. So tan of 30 degrees here. Tan, we're now working at this part of it. Tan is opposite over adjacent. So 1 over square root of 3. For 45, we're over here. Opposite over adjacent. 1 divided by 1. That's 1. You can write it as a fraction if you want to, or just as 1. Means the same thing anyway. 60 degrees, we're going to go opposite over adjacent. So that's square root of 3 over 1, or just the square root of 3. Now look at our 0 and 90. Now with tan, if you remember back here, our tan axis is up and down here. So when we've got a small angle, we just carry it on just a little bit more to get to our tan axis. A larger angle, carry it on a bit more. This one we'd carry on, it would be way up here. So tan is also going to start at 0 degrees, or start at 0 for tan of 0 degrees. As we go around, it's getting larger and larger, but when we get to this point here, we find that the angle of 90 degrees for tan, it's parallel to the axis for tan. So actually there's no answer for this one. It's undefined there, and it's going to be 0 there. Hope that video has helped you for absolute values of trig functions. See you later.